Welcome. Today we're going to be working in Chapter 7.6 doing graphing of square roots and cube root functions. So the first one I've got here is the square root. Now if we just graphed a square root, it would be a fairly simple process, but the trick to all these is we want to start, first of all, we know that we can't square root negative values in the real number system. So what I'm going to start with is I'm going to start with things that square root nicely as a substitution for x. So for example, I would start with 0, or whatever makes the inside 0. Because if we have adding or subtracting, I want whatever the inside is to be 0, because that is the furthest in one direction that we can go. So if I put 0 in, square root of 0 is 0 times a half is 0. The next perfect square is 1. So if I put 1 in, the square root of 1 is 1 times a half is 1/2. I'm going to keep going. 4 is the next perfect square. So if I put 4 in, square root of 4 is 2 times a half is 1. Notice this side is going progressively up by a half. Let's see if it continues. 9 is the next perfect square. The square root of 9 is 3. And 3 times a half is 1.5. You can see this side is progressively going up linearly, and this is going up exponentially. I think that's exponentially. 16 is the next number, which is going to be off my graph, and that's only going to be square root of 16 is 4 times a half is 2. So you can see that really I'm only going to put what's fitting on my graph for the most part. So my graph is going to start at 0, 0, go to 1.5, 1, 2, 3, 4, 1, 9, 1.5. You can see it doesn't go up very quickly. It goes out much faster than it goes up. So I just connect these with a little bit of an arc, and you can always graph these in Desmos after you've done it on paper to see how it should look and if it matches what you've done. All right, there is our first example. Now, the next thing we're going to talk about is domain and range. Domain in this problem is, of course, the x values. And the x values, if we look at this graph, the x values start at 0 and go up forever. So x is greater than or equal to 0. Now the y values, on the other hand, start at 0 and they go up very slowly, but they do go up. So y is greater than or equal to 0 as well. All right, so now if we think about it, if we put 100 in for x, the square root of 100 is 10 times a half is only 5, but it's still going up. So even so it takes a long time to get there, it does gradually go up. Let's take a look at another example. In this case, I'm multiplying by a negative number. Now, that's on the outside, so that's okay. I'm just trying to figure out what x values to plug in. It's a similar situation to the last one, where we're going to plug in 0, 1, 4, and 9. And those are the ones that are going to fit on my graph. If I put 0 in, I get 0 times negative 2 is still 0. 1, square rooted is 1 times negative 2 is negative 2. 4 square rooted is 2 times negative 2 is negative 4. 9 square rooted is 3 times negative 2 is negative 6. These are going by 2. These are going by exponent. All right, let's continue. 0, 0. Here's my 0, 0. 1, negative 2. 4, negative 4. 9, negative 1, 2, 3, 4, 5, 6. So this same kind of look is still happening. Remember, it starts here, it doesn't go any further to the left, but it continues down to the right. All right, so that will continue to go bigger negatively. The domain is going to be x greater than x, not y, x greater than or equal to 0. Because if you look at this side, it's all the numbers greater than or equal to 0. Now, just because I picked numbers that were 1, 4, 9, and 0, doesn't mean you can't have values in between there. We just tend not to use them because they're long decimals. Now, if we go to the other side, the range y is less than or equal to 0 in this case. Think of a line here. Where does it go? It goes down as it goes along. Whereas this going this way, it goes to the right as it goes along for the x and the y values. Take a look at another one. All right, this one's different. There's no multiplier in the outside, but there is an addition happening inside. So the question becomes, what value of x will make the inside 0? That will be the far end of one of these. So what plus 4 is 0? Negative 4. The next value, what plus 4 makes positive 1? Negative 3. What plus 4 makes 4? 0. What plus 4 makes 9? 5. And maybe even what plus 4 makes 16? 12. Now, your graph paper typically goes at least 13 in each direction. Mine only goes 10. But I'll throw that number in just for your graphing purposes. In fact, I could slide this, oh boy, I don't want to do that. I could slide this over a little bit so that we have enough room to do that. All right. If I put negative 4 in, negative 4 plus 4 is 0. Square root of 0 is 0. Negative 3 plus 4 is 1. Square root of 1 is 1. 0 plus 4 is 4. Square root of 4 is 2. 5 plus 4 is 9. Square root of 9 is 3. And 12 plus 4 is 16. Square root of 16 is 4. Now I can plot these points. Negative 4, 0. Negative 3, 1. 0, 2. 1, 2, 3, 4, 5. 3. And 10, 11, 12. About there. So when I graph this, it starts here, arcs up, and it keeps going in that direction, upward and to the right. The domain here is all x's greater than or equal to negative 4, because that was the smallest value we could use. The range is y's greater than or equal to 0, because they start here and go up, the y values. The x's start here and go to the right. Remember, x is the left-right movement of the graph, y is the up-down movement of the graph. All right, give this one a try. See if you can come up with the points and the domain and range. When you're done, unpause and see me do it. All right. What values of x make the inside 0? 1. Make the inside 1. 2. Make the inside 4. 4 and negative 1, 5 and negative 1 make 4. Make it 9, 10. And that's as far as I'm going to go. 1 minus 1 is 0, square root is 0. 2 minus 1 is 1, square root is 1. 5 minus 1 is 4, square root is 2. 10 minus 1 is 9, square root is 3. So if I plot these points, 1, 0, 1, 2, 3, 4, 5, 2, oh, I skipped 1. 2, 1, that's better. 10, 1, 2, 3. I still did 5, 2, that's fine, but I just did it out of order. My graph is the basic graph, it's just shifted to the right, where this one shifted to the left by 4. Oop. So back to this one. Domain. X's are greater than or equal to 1, as not 0, but 1. The range is y greater than or equal to 0, because it starts at 0, goes up. Let's take a look at another one. What happens when the addition is on the outside? This is very familiar. And the reason it's familiar is because this same type of stuff happened when we were working with absolute value, when we were working with parabolas in vertex form. When you have something, let's back it up a little. When you have something multiplied, it doesn't change where it starts left, right. It only changes how much or little it grows. This is growing small but positive. This is growing bigger but negative. So instead of up, it's down. This is 4 to the inside. It's 4 to the opposite direction, left. This was 1 rather, to the right, opposite the direction it looks like. This one, I expect it's going to go up the original origin by 2. Now, what value of x? This is x is the inside of the square root, the plus 2 is outside. So what value of x is 0? 0, 1, 4, 9. These are the ones I'm going to use here. When I plug in 0, 0 square rooted is 0, plus 2 is 2. 1 square rooted is 1, plus 2 is 3. 4 square rooted is 2, plus 2 is 4. And 9 square rooted is 3, plus 2 is 5. So when I plot these points, 0, 2, 1, 3, 1, 2, 3, 4, 1, 2, 3, 4, 9, 1, 2, 3, 4, 5. So my graph looks like this. My domain, x is greater than or equal to 0. It starts here and goes that way. Y, the range, I started to make a y, is greater than or equal to, it starts here at 2 and goes up. And there's your domain, range, and graph. What about cube root? Oh boy. Well, now please notice I'm going to start in the middle because with 0. Because when you're working with cube roots, please remember that the values that you can put in there are both positive and negative. So that's why I'm going to put 0 in the middle. The square root of 0 is 0. Now the values as I go positively are, now I know this is a little weird, but I like to, well, maybe I should put the, it doesn't matter. 1 and 8, -1, -8. You could have put them the other direction. It doesn't really matter as long as they're all there. The next one is 27, which is certainly not going to fit on my graph. I could do, for example, 1/8 and get 1/2, but I'm not going to do that. So the cube root of 1 is 1. The cube root of -1 is -1. The cube root of 8 is 2. Of -8 is -2. Now I'm going to graph. Now at first look, when you do this, 0, 1, 1, -1, -1. Looks like a straight line. It's not. If I put 8, 2, and -8, -2, now it's obviously not. Now if I didn't have this, it would look very similar to the square root graph where it goes like this. Kind of starts a curve and then almost plateaus, but doesn't really. But now it's got a kind of a flipped mirror image going down. So it's got this, look. The domain of this for the x values, all real numbers. Remember that? All real numbers. The range doesn't ever stop going in either direction. No, it keeps going. So all real numbers. You could also use that element, the set notation with the element, x is an element of the real numbers. This is a much more complicated version, but I bet you could figure out what this is going to do before we even start. It's going to be reversed from what it was before. It's going to be, the center is going to be shifted left 3 and down 4. Because the inside shifts opposite left right, the outside shifts exactly what it looks like up down. And this either flips it or leaves it the same. So, I need to come up with the values, let's start at 0, that make the inside 0. What x value makes the inside 0? -3. -3 plus 3 is 0. Square rooted is 0, cube rooted is 0. Times -1 is 0. Minus 4. -4. There's my starting point. Now if you have to put a little 0 here to remind you what number you're looking for, 1 and -1, -8 and +8, that might be helpful to put that in just to remind yourself that's what you're looking for. Alright, what makes 1? How about -2? -2 plus 3 is 1. What makes 8? What plus 3 is 8? 5 plus 3 is 8. What makes -1? -4 plus 3 is -1. What makes -8? -11 plus 3 is -8. Now I'm going to erase these just so that they're not in my way and they don't confuse me as I'm working my way along. All right. -2 plus 3 is 1. Cube root is 1. Times -1 is -1. -1 and -4 is -5. 5 plus 3 is 8. Cube root of 8 is 2. Times -1 is -2. And -4 is -6. Now, if this pattern holds, this should be a -3 and a -2. Let's see. -4 plus 3 is -1. Cube root is -1. Times -1 is +1. And -4 is -3. Sure enough. And -11 plus 3 is -8. Cube root is -2 times -1 is +2. +2 minus 4 is -2. Now let's do some graphing. I'm just going to work my way down. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Negative 2. 1, 2, 3, 4, 5. Negative 3. Negative 4. Negative 4. Negative 3. Negative 11. Negative 2. About there. All right, so there's my center, which is arcing this way, and then the other side is going that way. Domain, all real numbers. Range, all real numbers. You may say to yourself, is there any time with a cube root function like this that it's not all real numbers? The answer is no. They're always all real numbers because there's always everything you can put in as long as there's no exponent inside here and no absolute values. Then you're going to get all real numbers, okay? If it's strictly a cube root type function. All right, that is it for today. I hope that was clear.